as we are recording this, and then we'll be up in, we will send everybody a note, an email with the link to the recording so you can share this with anybody you want to share it with. There's Cameron. We have Cameron from Washington Gas. Jeffrey. Good. Okay. So this will be recorded and you'll get a link to the recording, and then we put it up on our YouTube site. You can use it in your training anytime you want. So we're going to minimize this. And so what is going to happen this morning is James is going to go off first. He's going to be talking about proper squeeze off, the selection of the tools, release, and static tool maintenance, squeeze off tool maintenance, and then the static control in that. And then after that, I'm going to address the issue of static in squeeze off. So with that, James, why don't you introduce yourself, and I will advance the slides for James when he's ready. And everybody can hear. I'm assuming everybody can hear. Let me give it. If you hold off your chat until after, if you have any questions. But if you can't hear James, just let me know. Hit me a chat and let me know. I'll assume that everything is okay if I don't hear from him. Okay, James, why don't you start us?
Good morning, everybody. Thanks for attending. This morning, as our main slide there says, we're going to talk about the proper squeeze and release procedures, and they're all going to be based off ASTM. Everybody's utilities are going to be different, but ASTM is a worldwide one, so we use that one in our presentation. Squeeze tool static suppression procedures, squeeze tool maintenance, understanding controlling static during a squeeze. Dirk, I won't steal too much of Dirk's thunder as I go, but some of the stuff I have to insert and say about as it relates to squeeze offs. So a little bit about change slides there, Dirk. About myself, I've been at Footage. I'm their technical training and sales manager. I started working at the back door, assembling and fixing squeeze-off tools in 1997, so a long time. And you can talk about yourself there, Dirk, if you want to just jump in there. Your Ionix.
Yeah, I've been involved in static suppression, in industrial operations for 25 years. And we also started being involved in static suppression in the natural gas downstream business. We're also starting to work in the production and gathering. And where hopefully the purpose of our efforts are to try to mitigate fires and explosions and improving safety in the downstream market. And that's why we're doing this. Okay, James?
Yeah, so sorry, I just want to back up the bus just a second. You can keep that slide there, Dirk. Everybody don't know Footage is a squeeze-off manufacturer for 1/2-inch to 16-inch PE mains and 3/4 to 12-inch steel squeeze-offs. So we had, just so everybody not aware what Footage does. That's sort of should have said that at the beginning, what Footage Tools is, if I wasn't sure. All right there, Mr. Dirk. Like today, we're going to cover just sort of a passion, my sort of passion of Footage is training. So tell me and I forget, teach me and I remember, involve me, I learn. So if I was involve somebody, get involved with the training department or show up on your site, we get you hands-on, piece of scrap and pipe from out of the dumpster. Let's get this so everybody's familiar with it. Everybody in the field has to know a whole whack of stuff. I have to know squeeze-offs. Everybody in the field has to know electrofusion, trench wall collapse, squeezing, butt fusions, all sorts of stuff they have to know. And just squeeze off one more thing. If we make it easier as a manufacturer, come in, involve people at early learning, just a win-win situation. So today we're not going to talk about any work that happens during a squeeze. It's sort of talk about the processes of doing the squeeze, setup, and then release. And some basic maintenance at the end of it. And like anything, training is key. Practice makes perfect. Rainy days, grab a stick of pipe out of the dumpster, whatever it is, try it, get used to it. Up next, we're going to look at what is a squeeze off. This definition is right from ASTM. It's a technique using manual or hydraulically operated tools to temporarily compress the pipe to possibly stop or control the flow of natural gas inside a pipe, aka flow control. And the big word there in red is possibly, because there's no guarantee from the pipe manufacturer, from the squeeze-off manufacturer, or even ASTM that you're going to get good flow control. So everybody knows that going in, it levels the playing field, if you will. Everybody knows what to expect. You may or may not get it, and that ASTM standard is from F1563 321 or 3.21. The pipe is changing shape. So you see the picture on the right, you start round, We go oval, and then we go flat. We're actually, those molecules, when that pipe is changing, it's called cold flow. So on the way down, we want to take our time, and ASTM says it's going to be a certain rate. I say with on release, when we go from the bottom back up again, from the flattened positions, back up to release and round again, we've got to take our time again. Those molecules have to reorientate themselves, and they call that cold flow. So we want to take our time, especially, and also below 32, we want to take even longer. Those molecules, much like us, when we're cold and stiff, we're probably not able to exert maximum effort because we're cold and stiff. With our bodies, our joints, and our muscles, same with that pipe. And then up next, we're going to talk about what is ASTM, who is ASTM. The American Society for Testing Materials. They have over 12,000 standards worldwide. Everything from machine gun barrels, implants, safety welding procedures, pipe manufacturing, squeeze-off manufacturing. They cover a lot of standards, keep everybody safe, and been tested and true. So there's two standards that squeeze-off manufacturers have to follow. F1563, about the design and how they're built. The squeeze bar radiuses, single bar, double bar, over squeeze protection, accidental release, workmanship, stuff like that, just doing a few things. Then there's also the F1041 for relates to everybody in the field, how it's used, how they should use it as it applies to pipe. So we talk about squeeze rates. They say 2 inches per minute or less. Release rates, 1/2 inch a minute or less. Static protection, why we're here today. Squeeze locations, you can't tape or near a joint, 3 times the pipe diameter away from a joint. Cold pipe, cold temperature, we touched on that a minute ago, about anything below 32, you have to extend your time or double it. Operator skill and knowledge are required too, per ASTM, to operate a squeeze-off tool and be familiar with them. Those are two standards. Squeeze-off manufactured for F1563 and then 1041, how they're used in the field. For the static protection on 1041, everything has to be grounded, statically grounded. Stealing too much of Dirk's thunder, but everything has to be grounded. Why his product and our static ground spike we have with our tool work hand in hand to be a safety feature. There's also ASTM. There's also a Plastic Pipe Institute has their technical note -54, and sometimes they say double squeeze and release times in cold weather. So they also say that, the Plastic Pipe Institute. So it's two big organizations know that data, that safety information that's been tested and true. Then we'll jump on, we're sort of talk about checklist A, our tooling, what we're going to look for. Well, we've got our spray from Dirk there. Once our pipe's exposed, we clean it, apply it. We're starting at the top there quickly. We're sort of, are the operators qualified, fully understand the squeeze tool operation and squeeze release processes per ASTM 54. The squeeze tool pump in good working order. Squeeze tool or pump, if it's hydraulic, are they in good working order, properly maintained and connected to the pump? The STM again is all dictate us, not the squeeze off manufacturer. Is the squeeze off tool properly sized? Are we undersized? Are we too big for it? Again, back to ASTM. The squeeze off tool, the right stops, over squeeze protection on it. Again, for ASTM, we don't want to over squeeze that pipe too far. And the most important thing while we're here today is, does a static tool, squeeze tool have a static grounding system and is properly affixed to a tool and in good shape? Else footage tools are a number 6 welding cable, so go right to the body of the tool, right to the ground with a brass spike, a great path to ground. And
James,
Dirk has it. Yep, go ahead.
James, can I ask you a question then? How do you make sure that the squeeze tool is properly sized for the pipe? How would a guy in the field know to do just a double check?
So what you'd want to do is you take your gauge plates on the side of the tool there, on our tool or any other manufacturer that be, make sure that their over squeeze protection settings are listed on there per your data stamp or print line on your pipe. Make sure they match.
Okay.
So if your pipe is if it's 2 inch 11 on your pipe, you better make sure that one of your over squeeze protection settings has 2 inch 11 on it. So they match.
Okay. Thank you.
No worries. And then
next slide.
Yep, please. We've got our tooling, and now we're going to touch on installing it on the pipe. So we'd make sure the pipe is clean. We're wearing our PPE. Pipe is in good shape and has clean, no damage. They would preclude it from being squeezed. I don't allow 10% surface to finish damage. So we want to squeeze on anything that's damaged. Best practice is to use the static grounding spike in the ground first before the tool touches the pipe. Dirk will talk about that more, but there's a reason why that's the best practice. To put that spike in the ground first, then put the tool on the pipe. It's operator protection to do that process. Ensure the tool is centered and square 90 degrees. So bird's eye view is at 9 square to the pipe. Landscape view is at 9 degrees to the pipe. And is it centered between the shafts, the sides of the tool? We don't want to have it go too close to one side or the other. We want to squeeze as minimal surface area as possible. Ensure the tool is placed no closer than 3 times the pipe diameter away from previously squeezed areas, elbows, tees, couplings, etc. And that's again per ASTM. And are the gauge plates set correctly or stops set correctly? Or is your bar put in properly or your gauge plate set in? Is your barrel rotated on different manufacturers? Are they set? Hit that bottom or top bar, make that squeeze per your print line on your pipe. And again, you can also see that it's all ASTM driven here, all but 2 of them. Or 3 of them, sorry, the top 3, the PPE and the no damage and static tool spike in the ground first. It's all ASTM driven. A good idea when you have that spike grounded, stuck in the ground, pour your half bottle of water, kick it around the truck or van, pour it around that spike so it just seats that brass spike, copper spike, whatever you're using, gives it that much better of a connection to ground. And dry, airy dirt with air between it, this gives a nice solid connection to ground. All right, Dirk. And check C, we're starting the squeeze. Get everybody on the job sites ready to go. We're mindful of our training, of our squeeze rates, procedures, and training. You know, what we want to follow the steps. Is there lockout, tagouts involved? Is it fire suppression on site? Everybody's on the right page. As the squeeze bars come together, double check. On our tools, you can double check that our gauge plates are set right. As they get closer, you can get bumped by a boot or a pant leg or rope or whatever it might be in the trench. But you're still set correctly. Little known fact: per STM, keep squeezing until the flow of gas stops, where the flow gauge plate or stops have been contacted, whichever comes first. That's ASTM. So we don't have to keep going if the gas flow stops on electronic metering or digital metering downstream stops, and you still have 1/16 of an inch gap between your stops. That's as far as you go. Again, those stops on any manufacturer are there to prevent the over squeezing in the pipe. So we want to go to them. We don't go any farther than them. Those stops. So yeah, stop when the flow of gas stops, which are the contacts come in place first, whichever comes first. And that can be verified how your squeeze is progressing if you have flow control, that we touched upon earlier, with your electronic instruments downstream. Or if in a calamity based, you would know by a dust storm downstream from your satellite pit, screaming pipe, where that backhoe bucket is in that pipe. You'll know that once you got a good squeeze, that sound will diminish, the dust storm will go down. And you also have, if it's maintenance related, you could just put your electronic sniffer on there with your key and see if you've got the gas flow has stopped. Yeah, certain instances, the operator may know visibly audibly what has flow control been achieved. And then once you've got your squeeze down to your stops or the flow stopped, activate or install any accidental release devices that came with the tool. That's the unlikely event any of the hydraulic pressures ever fail, that those bars are maintained together. They're not going to jump open on you. Okay, so now we're not going to talk about what happens during the squeeze, after it's squeezed, you know, the work involved in there. We'll jump to the next one, please, Dirk. And then our checklist D, the release. After all the work's done, everybody on the site again has said, yep, we're good to go. We're going to open it. We're going to purge. We're going to move forward. We're going to do our release, deactivate or remove any accidental release devices we've installed. We want to start the release process, be mindful of our company's training rates. You know, we want to make sure we follow them. Again, that's per STM, following those rules of your training. Once the pipe is ceased rebounding, squeeze off tool can be removed. ASTM has also proven that the release is the most important part, where that pipe could be damaged the most. So we really want to take our time. Obviously, we're gassing up again. We want to make sure we don't flood that system with a rush of gas. We want to make sure we just open it a little bit, crack it, let that pipe, much like our muscles, sort of cold joints, cold muscles in our body, let them warm up where they take the maximum load. And again, they want those pipe molecules and we go from that flattened state back to round again, that they don't damage them. Keeps the
And
integrity.
so James, if I can jump in. So when I noticed here earlier, you can squeeze down at 2 inches per minute, but the release time is 4 times slower. It's at a ½ inch per minute. So you want to slowly release that pipe because you have damaged it and because of the cold flow of the molecules.
Well, you haven't damaged it. We don't want to damage it. We want to make sure we go even slower.
Okay.
Again, we've taken that from round to flat, and then we want to go back again. So those molecules have had a big workout, if you will. They run a big race. They want to make sure that they stay integrity. The pipe is there. So we're not damaging it. We're just, if we go too fast, then we are damaging it. They could crack at that point. That's why that rate is so important. That ½ inch a minute. Take your time.
So that release rate really is more important than the squeeze rate.
Oh yeah, for sure. Because that's okay. We've changed the whole shape of that pipe, right? Okay. So we want to make sure we follow that, and we're not in a hurry to go home in the afternoon. We want to make sure we get it done properly. And then the freshly squeezed area can be marked, identified as utility procedures. We identified so it's already squeezed and never squeezed again in the future. Certain tools, one of ours has a CRV, or a controlled relief valve on ours, so it gives approximately ½ inch a minute. I say approximate. Is it January in Boston, or is it January in Miami? The pipe's going to be racked differently. Is there 60 pounds inside, or is it 80 pounds inside? Is there 40 pounds inside? Is it SDR 9 or is it SDR 13.5? What's going to, these variables come into play. But that CRV we employ with our hydraulic tools gives you a whole lot more control for your release, keeping us very close to that ½ inch a minute. And then keep the static grounding spike in the ground until that the tool is removed from the pipe. We don't want any chances of anything. As we're gassing up again, that gas is going to, as Dirk's going to talk about it. So again, raining on his parade, gas is really screaming back through there again. Once it gets going, we start opening it, increased risk for static discharge. We'll go to the next one, please there, Dirk. A little bit of basic maintenance. And again, these are a couple of pictures in the next slide there, Dirk, of some footage tools of some worst case scenarios, the operators that are places that I've seen over the years that have had, so you can see the left picture at the bottom, left red arrow, the ground spike's broken right off. Obviously it cannot be used. And then the ground spike has sort of been the ground cable has been attached, just frayed off like that. And then the right-hand side, just basic maintenance, or maintenance, like any tool, be a chainsaw, lawnmower, and just basic maintenance to it, keep it clean, so it's ready to go. Because most emergencies happen not at 2 in the afternoon, but at 2 in the morning kind of thing. So you want to make sure it's ready to go. And then we'll go to the next one, please, Dirk. We'll have a little bit of maintenance. Again, this goes to any squeeze-off tool, not just ours. We want to make sure we clean the entire tool, prevent any potential binding, unnecessary friction, moving parts. We want to clean them all, lubricate them too as well, per manufacturer's instructions, for any undue wear. We want to test the tools regularly too for correct operation. That comes back to what I talked at the beginning, where rain day, nothing's happening. Grab a stick of pipe out of the dumpster, test it, test that tool, make sure it works, make sure you're familiar with it. Make sure our static grounds cable is in good shape and firmly attached, not like those pictures we just saw where it's broken and frayed. We want the most direct path, almost like taking a direct flight versus connecting flights. You want to get that direct path to ground. Your oil level in a hydraulic system is all topped up and it pumps. Visually inspect the hoses, gauges, fittings, and possible damage or leaks. Some of them can be high pressure oil. We don't want them to have an incident. And report and repair anything that's damaged. You see during a job, after a job with the squeeze tool, report it. Can't move that unit from service. Again, it's very key that all those squeeze tools are looked after very well. Almost babied in one sense that they're maintained that way, because when emergency, they're going to work flawlessly. And this is just the bare minimum. You can do more of this stuff if you wanted to, more testing, more, yearly inspections for them, that kind of thing too as well. I just want to sort of stress again, note number 3 here in red, number 3, test, get good practice with it. And our next slide there, Dirk, I'll wrap up my segment here where don't practice till you get it right, practice till you can't get it wrong. And this all I do is squeeze off, so I can do it in my sleep. But if you practice with it, become more familiar with it, it just becomes second nature. So at 3 in the morning, when you have to deploy a squeeze tool, you know how to operate it. So that's my key. Everybody can take away today to be safe. Train up, get knowledge how these tools operate. Reach out to me yourself. We set something up. I can come in to visit. You're with the training department, train the trainer kind of thing. We can make sure everybody's on the same page and understanding fully all that kind of good stuff to operate properly. That's it for me. I'm going to wrap up. Thank you everybody for that. And if next slide is questions, we'll hold them off, like Dirk said, to the end.
Okay, James.
I'm gonna mute out here, and I'll ask you a question. I'll think of some good questions as we go.
Okay, great. James, thank you very much. Well, some of you may be wondering, why in the world did James and I get together to talk about squeeze-off tools and controlling static electricity in squeeze-off? And the reason is because in your squeeze-off operations, you create some of the highest static charges that you will find in O&M operations. It's a procedure that creates static, and then you're putting people in proximity, you're cutting in the pipe, and like James said, squeeze-off doesn't guarantee complete gas flow cutoff. And so you have a gaseous mixture, you have people in the trenches, and gas is very unforgiving mistakes when static electricity is present. So because of that, that's why we paired together to do this presentation. Now I'm going to take a little side jaunt here. This is a slide shared with me by David Zach, who used to be at Ameren for 20 years, who is now a senior utility loss consultant for Aegis Insurance. Aegis Insurance is probably your insurance company. You may not know that, but they probably are, because they insure virtually every single natural gas distributor in the United States. They're a mutual company. In other words, this is an insurance company that's owned by the customers, okay? This is a pie chart of what Aegis paid out. I think it was the year 2022. It's a pie chart of the total amount they paid out in claims by the nature of the claim. And I want you to see here that over 81% of the claims that your insurance company paid out was not for a vehicle accident. It was not for a wrenching accident. It was not for property damage. It was not for environmental damage. It was from fire and explosion. It's more than all the other claims combined. So when we're talking about squeezing off a pipe, cutting it can't be 100% sure you got gas flow stoppage and you've got workers present, minimizing the risk of a fire explosion and minimizing the ignition source is a key step in reducing the risk factors in your operation. And that's why James and I are partnering in this. Now, you need squeeze-off tools because, I mean, that's just in the downstream market, you just have to use them. And so you need to be prepared to operate them right, to maintain them right, and then understand what are the static threats caused by squeeze-off. Well, there's three of them. A worker can get shocked. Obviously, there can be an ignition. It also creates pinhole leaks in the areas you're working on. So let's talk about this. How static created? Well, what happens is your compressors, when you're forcing that gas through a pipe, the velocity of the velocity of the gas going through the pipe, the friction inside the pipe, shears off electrons in the passage of gas inside that pipe. And so what happens is these electrons kind of become orphan electrons. They start to float around inside your pipe. And for some reason, we don't know why, they start to accumulate in certain areas and they build up. And these charges build up initially on the inside of the pipe, and then in turn, they induce a charge on the outside of the pipe. Now, we're just talking about just the normal operation of a pipe. Now we're going to add in squeeze off. Now, when you're getting ready to squeeze off, remember, let's assume that you're going to be working in the same trench that you're squeezing off. The same will still apply if you have a bell hole, but let's just assume for simplicity's sake, you're going to squeeze off in the same trench. Because static is generated inside that pipe, it induces a charge on the outside. Once you excavate that pipe, you want to make sure that you dissipate the static on the outside of the pipe before you place any tool on it. This will dissipate any existing static charge on the surface of the pipe. Now, what happens at squeeze off? Why is this such a big risk at squeeze off? Why is static such a big problem at squeeze off? It is because when you start to squeeze down that pipe, the Venturi effect takes effect. What happens is the diameter of the pipe, as it starts to get reduced, the gas initially will try to speed up to go through the narrowing opening. And so there'll be a greater velocity downstream. There's greater friction downstream on the inside of the pipe. That in turn will generate more static electricity on the downstream side of the pipe. It also does generate static on the upstream side of the squeeze off, but not as much. And that's why you always want to ground your tools, put your grounding spike in the ground before you place the tool on the pipe. And what happens is, as you start to reduce that flow, the static starts initially on the inside of the pipe, but now that inside static is going to induce a charge on the outside of the pipe. Now, if you're putting that tool on that pipe and starting to crank that down, if that charge happens to arc through that pipe wall to the tool, if you don't have a grounding strap, that charge will conduct through your worker, shocking you. So that's why we want to make sure that you always ground the tool on the squeeze off tool prior to putting it on the pipe. Now, if you do ground the tool, then that charge, if it happens to arc through the pipe that's been generated by the squeeze off, it will go through the grounding spike, go through the tool, through the grounding spike to the ground. And as James said, it's important to make sure you have good contact. Take some water when you spike it, pour some water in there to make sure you've got a good connection. And the other thing that's often asked of James and I is how thick does the grounding line have to be? The grounding strap doesn't have, whatever's initially installed on the tool will be fine, as long as you maintain it and you have a good connection. Static electricity in these instances has a very high voltage, but it has no current. In other words, when it arcs, it's going to be over in a second. If you put your finger in the wall down here in Florida in my office, and you put your finger on it at 120 volts, my finger will conduct 17 amps until that circuit breaker trips, because there's a supply of electrons coming behind it. In the case of static electricity, once that static charge is grounded, there's no continuing generation of electricity to keep up that voltage. So there's a very high voltage, but very low current, and it's over almost instantaneously. So what happens is, I've had instances, we're going to be talking about one in a minute. I've had instances, where ignitions have killed people. I've never had a shock hazard kill somebody, but there was a close one. Steve Jocelyn used to be with Connecticut General, now with PAL up in New England, told me an incident up in New York State where a worker in a trench, the static charge arced to him and it went through him down through his foot. And first of all, it burned his big toe so bad that the static discharge through his foot. They had to amputate his toe, but they had to defibrillate his heart. So I have not had a fatality in this, but I've had numerous instances where the shock has sent somebody to the emergency room. So you have to treat this seriously. Now, it's important to remember that your tool grounding is a worker protection. It is not a static suppression procedure. Those are two separate things. When you ground the tool, and this applies to saws, drills, tapping equipment, anything else, the reason you ground those tools, if a static discharge should come from the pipe, it will not go through the worker. But that does not dissipate the static charge on the surface of the pipe nor inside it. It just protects the worker. The grounding of the tool does not ground the charges on the pipe surface. So to reduce that risk, what we suggest you do is that static charge is going to be on that pipe until you dissipate it. And so what we always encourage you to do is, when you've done your squeeze off, dissipate the static charges prior to entering the excavation again. So if you've dissipated the static on the exposed pipe first, that's kind of a good first step. Once you've done the squeeze off, spray the exterior again. And we have a reach tool that allows you to spray and apply the anti-stat from a distance. Now, let's suppose now you've done the squeeze off and you've cut the pipe, you're going to do something. again, because of the high charges generated inside the pipe, if at all possible, you want to spray an anti-stat inside the pipe. It will not affect gas quality. You're not going to put enough inside that pipe to make any difference to the gas when it goes through. But you will then dissipate the static that's been generated on the inside of that. We're primarily talking downstream. You also have to remember there's static charges inside that pipe and outside, upstream. Most of it is downstream. And again, if you have a bell hole and you've done the squeeze off, you can, how far down the static is generated from a squeeze off, you know, nobody's done any research on that. I really can't tell you. But it's better to err on the side of caution. Okay, Memphis Light, Gas, and Water. November 25th. Where's my date? It's November 26, 2014. Description at 10:30 at the very bottom. 10:30 a.m. on November 26, 2014, 5 employees were caught in an explosion due to a natural gas leak. Static electricity ignited the gas leak, and 1 employee was killed with 4 others burned. A couple things to note on this. What had happened was this is a routine street O&M operation. Memphis Light, Gas, and Water was not fined by OSHA. I'll say that again. Memphis Light, Gas, and Water. They found nothing wrong with their training or procedures or anything like that. What had happened, there was a squeeze off in that excavation and a pipe was cut. And somehow or another, and you have to think about what's happened here. How would this happen? But there were 2 guys in the trench, and somehow or another there was a blowing line with under full pressure with 2 guys in the trench. Now I cannot verify this. I cannot say I know for sure, but I've heard anecdotally from people who are present that they'd squeezed off the pipe, cut it, and when they found out it didn't give enough room for the operation they wanted to conduct, they released the squeeze off tool to move it back in order to re-squeeze the pipe to give them the room they needed. Again, I have no idea. This is anecdotally, I cannot confirm this. But somehow or another, there were 2 guys in a trench with an open blowing line, a cut line, which had to have been squeezed off. Your procedures that you develop for those guys, it is important that you not only make these procedures, put these procedures in effect, but you field audit them and make sure your guys follow them. I can't impress upon you how serious it is. Gas is very unforgiving of static electricity when mistakes are made. So if you're a guy in the field, I want you to remember this face. If you think you want to skip your static suppression procedure, you remember that face, and I want you to rethink your decision, because what we're talking about here is really serious. You need to follow your static suppression procedures when you're doing squeeze off. Now, the second issue that comes about with squeeze off is squeeze off creates pinhole leaks in pipe. On the left, you're going to see a paper written by Mark Staker. It was presented at the Plastic Pipe Symposium. And the purpose of it was to explain how they had found when they were doing squeeze off, after they were finished their O&M operation and they checked the pipe, they'd soap the pipe for leaks, they were getting pinhole leaks in the pipe that they had worked on. And they found this was consistent with other operations where they did squeeze off. And what had happened, they sent the pipe to the lab to be tested to find out what the cause was. And the lab said it was caused by static electricity buildup on the inside of the pipe, arcing through the pipe wall to ground itself, and it burned a hole. On the right, you see an electron microscope of a piece of yellow poly, and you notice how it has a filigree pattern. It looks like a lightning bolt. And that's exactly what it is. It's a lightning bolt created by the static that built up downstream of the squeeze off, and it got so high that even though plastic's an electrical insulator, it arced through the pipe wall and grounded itself. And in doing so, if you notice right in the middle there, it's black. Now, you know, yellow poly pipe doesn't have black inside it. That black is burned polyethylene. The heat of the arc, when it arced through the wall from the inside out, created enough heat, it burns the plastic and it creates a channel that leaks gas. So therefore, whenever you do a squeeze off, after your repairs are completed, you want to soap off all your exposed pipe for pinhole leaks. So,
Dirk, it's
yes,
James here. Is there a way to prevent pinhole leaks?
no, unless you get
No.
rid of the static inside. We have a system. We have customers that installed our internal static suppression because they were getting pinhole leaks from static, the normal transport of gas. And what we've done is we've seen reductions in leaks of 88% in one case, where when we reduce the static inside the system, the naturally occurring static, we reduce pinhole leaks. So when you're doing squeeze off like that, unless you have a system like that, no, there's no way to prevent pinhole leaks because you have to prevent the static buildup inside of the pipe. And there's really no way to do that unless you have interior static suppression.
Okay, well, thank you.
So in review of my points then, squeeze off creates some of the highest static charges the field worker will encounter. And because of that, it ignites gas, it shocks, and it creates leaks. So it's an injury and integrity work issue. It's important, as James said, make sure your guys don't disable the grounding straps on the tool. It's for them, it's a worker protection, but it's not static suppression. Those are two separate issues. Grounding the tool does not dissipate the static on the pipe surface, and it does not dissipate the static inside this pipe, as James was asking about. You must dissipate the static created on the pipe surface by squeeze off with anti-stat because you can't ground it. In other words, the grounding tool will not do that. And always check for pinhole leaks on both sides of the pipe, both sides of the squeeze off before burying the pipe. So with that, James and I want to thank you for that. If you have questions, if you want to chat some questions in, we'll be glad to take them. Just get this opened up. If anybody has any questions, anybody? Last call.
Even speechless.
Speechless. Well, we're going to thank you all for attending. And James, thank you for help putting this together. And I'm going to send everybody an email with a link for recording and so you can view it. Should tapping T tools be grounded? Ed Collins to everyone. Yes. What happens is inside a pipe, there's random statin. I'll go first, James, and then if you don't mind, and then if you want to add something.
You got this one all figured out.
Static is generated through the natural passage of gas inside a pipe. You don't know where that is in that pipe. So when you sit there and tap into a pipe, you could tap into a hotspot of static electricity inside that pipe. So one, yes, the tool. I recommend all tools be grounded. Saws, tapping T tools, drills, squeeze off tools.
Yeah, guillotine cutters too. I'll add that in there too.
Guillotine cutters, anything that's going to cut into a pipe that's been under pressure, under service, transporting gas, there's static inside there. The other thing we recommend to do is when you have a tap, spray, when you fuse the tap, spray inside the tap with our anti-stat. So what will happen is that our anti-stat will be carried into the inside to the cut. And if it encounters any static inside that pipe from the drilling and the cutting, it will neutralize that charge, whatever comes in whenever the liquid anti-stat comes in contact with the static charge. It's a little extra measure protection. I've seen guys, they've sent me a picture, they're trying to put a copper strap inside a tapping tool. I mean, it just ain't going to work. And this is where our anti-stat works very well. It's very simple. You spray it in there and it'll just get carried off. James, can you want to add anything?
I was just going to say that also goes for steel, Ed. You'd want, again, steel's always buried in the ground, but it's going to have some sort of coating on it, insulating it from that pipe going to ground. So I would, and that when it's tapping your T. Williams's or Mueller steel tapping stuff, I would still ground that stuff too. Again, there's still a danger with steel because it's coated, corrosion resistance or coating put on it. You want to, because again, it's not direct steel on the ground. It has a coating on it. You want to make sure that is grounded. Anything you have like that. Even our steel squeeze offs come with provision for grounding. We don't include it because again, the pipe is buried in the ground and it's going to have a chance to not build up. It's not the same as polyethylene. Dirk can elaborate more on that, but it's going to be grounded more. But there's still provision for it. If you want to do it, it's still a good idea. And so the belt and suspenders, if you will, for steel pipe.
Yeah. Yeah, James, that's excellent. I forgot about that. I made the presumption that he's asking about plastic. But if it's a steel tap, the same things apply. Coatings act as an electrical insulator, and static charge, as James said, can build up on those. So you should always use the same precautions when you're tapping steel as you're tapping polyethylene. Does metal pipe conduct electrical charges better than polyethylene? Absolutely. But that doesn't mean static charges can't build up. So you need to take the same precautions with steel as you do with plastic. Thanks,
Okay.
James. I'd
There's
forgotten.
live in person. There is live.
No, thank you both. I appreciate it. My original thought was on plastic, because that's where a lot of questions do come up about, do we need to do this? And, I appreciate you, explaining, the protection of the worker. That's what we're
Yeah.
doing it for. Okay.
Sure.
Okay,
Thank you,
thanks.
Ed. Thanks for the
Thank you.
question. Any other questions? Well, hearing none,